In this video, I want to share some more practical problem solving regarding the mathematical concept of shaded regions in geometry. So let's dive into the video. Focus on problem number 3 of the shaded region concept. So let's read the problem. It says, John T has a storage container in the shape of a cuboid as shown in the diagram. So this diagram shows that John T has a storage container in the shape of a cuboid. So John T is going to paint the outside of his storage container apart from the base, which is shown shaded in this diagram. So this shaded region, apart from this shaded region, John T has to cover the entire cuboid. So he needs enough paint to cover the four sides, these four sides, and the top. So each tin of paint covers an area of 15 meters square. So the cost of each tin of paint recently increased by 10%. So after the increase, the cost of each tin of paint is 26.95. So after the 10% increase, the cost of each tin of paint is 26.95. So John T says, before the increase, I could have bought enough paint for less than 200 pounds. So you have to prove that this statement of John T is correct, and you have to show the working clearly. So before calculating the cost, I have to actually figure out how much area John T has to cover, so that they can, when after we figure out the number of area or the amount of area, then we can calculate the cost. So in order to figure out the area, we first figure out one rectangle and then multiply it by 2, then this rectangle and then multiply it by 2. So if I focus on this, let's say the total area is T of surface area minus the shaded region. This is what? This is the area. Let's say this rectangle is 12, the length is 12, the width is 3. So the length is 12 and the width is 3, and this rectangle is also the same. So if I multiply it by 2, then I add this rectangle, which has a length of 3, a width of 2.5, a length of 3, a width of 2.5, and the back side, which is this one, is also the same. So I'll multiply it by 2, and the top part is what? This top part is the same as this shaded region. So it's 12, the length is 12 and the width is 2.5. Width is 2.5. So I get what? The total is 12 multiplied by 3 multiplied by 2 is 72, plus 3 multiplied by 2 multiplied by 2.5 is 15, plus 12 multiplied by 2.5 is 30. So I get a total of 117 meters square of area that John T has to cover in order to do the entire paint. Figured out how much area John T has to cover. We can now focus on the costing. So each tin of paint costs 15 meters square. So the total area is 117 meters square that John T has to cover, and the number of tin cans we have to figure out. So each tin paint is 15 meter, covers 15 meters square. So how many tin paints, let's say n, is what? How many tin paints John T requires? So the total area that John T has to cover is 117 meters square, and each tin paint covers 15 meters square. So if I divide 117 by 15, I get what? If I use the calculator and divide 117 divided by 15, I get 7.8. So 7.8 is the number of paints that John T require to cover the entire area, surface area. So if I go to the problem, so this is the this is the area, the number of tin paint covers that John T require. So the cost of each paint increased by 10%. So let's assume that the cost of each tin paint is X. So the 10% increase, or 1.10 of X, is what? Is 26.95. 26.95. So what is the actual cost, or what is the value of X? The value of X is what? The actual cost of each tin of paint is what? Is, if I use the calculator, 26.95 divided by 1.10 is 24.5, is 24.5. So 24.5 pounds is the cost of each tin of paint without the 10% increase. So now what is the total cost that Jonty has to incur? Each tin of paint, each tin of paint costs 24.5 pounds, and Jonty needs 7.8 pence. So what is the total cost? Let's say the total is T. So the total cost is what? 24.5 pounds multiplied by 7.8, the number of tin paints that Jonty required. So if I multiply it, 24.5 with 7.8, I get 191.1. 191.1. So 191.1 is less than 200. So this statement that before the increase I could have bought enough paint for less than 200 pounds is actually correct, and Jonty is correct in his evaluation. So this is how you can show that Jonty is correct in his evaluation and show his workings by calculating first the total area that Jonty has to cover, then the cost of each tin of paint, which is 24.5 pounds without the 10% increase, or before the 10% increase, and then we can calculate the total cost and show the workings clearly. We'll focus on problem number 4. So let's read the problem. It says the diagram shows a solid prism. So this is a prism. The cross section of the prism is shown shaded. So this is shaded. The entire volume of the prism is 924 centimeter cube. So you have to work out the value of X. Okay. So if I want to calculate the entire to find the X, I have to calculate the entire volume of X, entire volume of prism, and match it with 924 so that we can find out the value of X. So in order to find the entire volume of the prism, I will focus on these two parts. If I give a cross section here, it will have two parts, two cuboids. One is this one and another is the base, this cuboid. So I'll individually calculate the volume of each cuboid and then add them and equal them with 924, equal the total or sum with 924, then we can find the value of X. So let's try this one. So if I use my pen tool, I'll first focus on this part, the volume of this portion. So the length here is given is actually given. So this part is 6, as you can see is here. This part is 7.5. So the total is 7.5 plus 6, which is 13.5. So the length, let's say the entire volume, let's say V, is the first part, which is what? 13.5. 6 plus 7.5, which is 13.5, which is the length. 13.5 multiplied by the width is 8. As you can see, this is also 8. So the width is 8, and star, let's just give star to represent multiplication, and then multiplied by the height. The height is what? The height is X. So you have to figure that out. Okay. So this is one part, which is this part, Now I have to figure out the volume of the cuboid of this part, this portion. So this portion has a length of 8. This portion has a length of 8 star. Width of what? The width is given as 6. The width is given as 6 star. The height is what? The entire height is 14, and this portion, which is this portion, is x. So this height is, or this height is 14 minus x multiplied by let's just give a bracket, so it's 14 minus x. So this is the entire volumes, or the entire volume is given as what, 924. As you can see, this entire volume is given as 924. So 924 equals to what? 13.5 multiplied by 8 is what? If I use the calculator, if I just use the calculator, let's say 13.5 multiplied by 8 equals 108. So this is 108 x plus 8 multiplied by 6 multiplied by 14 minus x, which is 48 multiplied by 14 minus x. So we can calculate this as what? 108x plus 48 multiplied by 14 is what? 48 multiplied by 14 is 672. 672 minus 48x. 672 minus 48 into 14 minus 48 into x. So 672 minus 48x. So 108x minus 48x is 60x. So 60x plus 672. So the value of 60x, we can also write the value of 60x is what? 924 minus 672. So this is what? This is 924 minus 672. I get 252. So this is 252. So x is what? The value of x is 252 divided by 60. So it's slightly over 4. It's slightly over 4. So this is the value of x. So if I divide 252 divided by 60, I get what? 4.2. So x, the value of x is 4.2. So this is the value of x as per the equation. Hopefully by now you already have a good understanding of how you can solve the mathematical problems regarding the geometry concept of shaded region. So in the next video I'll come up with some more practical problem solving, so stay tuned for that.